The audio rollout, the engine that drives all the reaction. For this test, I'm going to start fresh. I'm going to clear my array. We have two quick options before we add the audio tracks. We have the custom start time. So if you have a track and you're trying to diagnose or work on a specific part of that song with the material and object reactions, you can choose a custom start time in seconds for it to start from each time you hit play. So that's all that is. That way you don't have to start your track from the very beginning each time you're trying to adjust something, maybe a minute into the track, and you find yourself having to wait a long time before you can actually get to that moment and see how all your changes have worked out. So that's what that's for. We have our master light and object gain. This will control, basically the master light and object gain, how much the lights overall will react to their respective audio stems, and same with the objects. And the audio peak values, this is basically a clamp range. So it's saying if my audio in is from 0 and there's a max peak volume of around 0.5, it's going to scale that up from 0 to 1. That way all the options going forward in our mesh and our light reactions are a bit more predictable. We don't have to go so extreme with our values to get a decent reaction, because the audio that comes in typically, even for louder sounds, doesn't come close to the value of 1. They're usually pretty soft. Even in some of my louder tracks, I find that the max values are around 0.35 to 0.4. With the audio signal turning into a float value, it never breaks 0.5 in my cases. So I set that around 0.5 as a default ceiling. You can scale this accordingly. It's very sensitive, so only go down a little bit and up a little bit and see how all the default reactions are working before actually going through and adjusting for, say, like your light intensities. I would make sure you have your peak value set first before adjusting any other value. That way you have a decent baseline and you have a good minimum and maximum value range set for your specific needs. And it will be much easier to set everything else for the rest of the project. Now for the audio stems and tracks. I'm going to start from a fresh array. I'm going to add 4 elements. Now, as with all my other arrays, you can add as many as you want and really go crazy on the amount of audio tracks you have in here. And they can be sound effects, they can be really anything you want at all. So let's just start with our default 4. And let's put in some drums. We're going to put in the bass. We'll do some instruments. And we'll throw in our melody. Now I like using Epidemic Sound because their tracks typically come with these stems already split out, and they're named drums, bass, instruments, and melody. So it works perfectly. Now this attack time and release time, the default is 10 and 100, but I made them 25 or 125 just to give the audio a bit smoother reaction. That way the objects and lights don't have jittery effects on the start and end of a reaction. So this basically is a smooth in curve slightly on your audio. And if you're finding you're getting reactions that are still too jittery and out of control, you can just raise this up. I go to 50, go to 100, even 200, 300, you start getting really soft reactions. But you just kind of play with that and set it to taste. Same with the release time, although I find this isn't as important. The attack time is the one I change 80% of the time when I'm having a reaction I need to adjust, or it's just hitting too hard or too much jitter to where it looks like an artifact or just something unintentional. So these stems, they come in with their index number 0, 1, 2, and 3. And these index numbers will be used across all your other reactive parameters, all your lights and all your meshes, and eventually your materials. So for instance, we'll go into index 0, which is our table down here. You can see he's currently reacting to 3. So that's our melody. If we set him to the kick drum, or the drums, which I know is 0, let's fire up simulation. There we go. You can even see my light intensity I have selected changing real time. as it reacts to its own song stem. So let's change the table to the bass now. So you can see how simple it is to add an object, add a light, choose the stem, and just start having some fun. The automatic mesh and light tagging system can be very useful for managing large amounts of reactive assets. In this scene, I have all my tags visible, and in our details panel, we have a hide tags in game, which will come by default on. So if you're not in game mode, you'll still see them, but while you're playing, you will not. However, there may be an instance where you want to see these in simulation, in which case you can leave them on and just hit Alt-S to simulate, and you'll see the tags are attached to their parent objects. Our meshes have tags that will not face camera as you move. The light tags are completely tied to the light's rotation, so they'll always be on the front face of the light itself. But with mesh tags, you'll see now I'm behind all the tags and everything's backwards. I have a quick workaround. Basically, you can choose any camera in your scene. I made an example camera called Audio Reactive Tag Cam, and in your details panel under viewport tags, we can choose, so let me clear this, I can choose the Audio Reactive Tag Cam. And here you see as I remove the camera, they all went to facing the way the mesh faces. So if you leave the camera blank, these will all face the direction that the mesh is in world space, or in relative space. So let's put in our tag camera, and this could be helpful to always get the tags to face you, no matter where you are. So as you move around, if you click any option in the blueprint, it'll force a recompile, and they'll all start facing you. So that's the one thing I need to work around, is how to make this all automatic, but for now, once you're done moving, just click any option in the blueprint and it'll recompile and it'll force all the tags to face you. So that is the mesh tag facing system. You can also change the scale and the vertical spacing to move them up and down from the meshes. I found these are the most handy options in my research and development that I would use when trying to work around tricky meshes to be able to still see the tag. And as a final shortcut, if a tag, for instance, is kind of hidden in the wall, you can always select any one of the tags, which selects the blueprint, and now you get a nice outline that you can actually see through pretty much anything. So you see I have a floating guy up here. So now I know mesh 26, that's actually all these curtain objects, but they're all one object, so the tag itself is centered on the mesh. So those are my curtains. Now these tags will correlate to the indexes in the mesh and the light arrays, which I will go over next. So now we have our meshes and our light arrays. We'll start with the mesh array and move over here real fast. Okay, so we'll start with mesh 0, which was the first index that I added. As you can see, I have 31 total. So this will show you how important it is to have this, at least some kind of visual ID tag, because as you add a lot of objects, until I have a cleaner widget UI to handle all this, for now we're just using indexes. So this number here will correlate with the number on the tag. So if we go to mesh 3, this should be the magazine. So go to index 3, you see we have our magazine right here. Now with mesh tagging, any static mesh by default in most scenes that you open up are going to have the mesh set to static. Now static is going to throw errors when you try and play using the audio reactive system. So instead of manually having to change your meshes to movable, this blueprint will do it for you. So as you can see, I've changed the magazine back to static. If I choose my eyedropper, click the magazine, you can see that it's now movable again. So you should not have to worry about making anything movable, but keep this in mind for performance issues. If you have a large amount of meshes and you want them to be static during gameplay, that would have to be just a separate thing you set after the fact, knowing that for now, this system will make them movable permanently until I put in switching logic, so when they're removed from these arrays, they can go back to being static. So just keep that in mind for now. That'll be in a future update. Okay, so for these meshes, we have our audio-driven parameters. We have our scale, we have our translate and rotate, and we can choose each axis from each transform that we want to have react to an audio track. So for instance, this magazine is rotating on Z by a value of 500. Now this is basically 500 multiplied by the incoming float audio signal, which is always less than 1, and it's typically less than even 0.5 or 0.4. So this may seem like a high value, but it's multiplying by a very kind of small incoming audio value. So this is in no regards like a rotation degree. This is not like translate in units. These are all multipliers multiplying by the incoming audio stream. Now for this magazine, I have the stem selection on 3, which is our, where are we at? Let's go down or up to our audio drop down. Audio, so index 3, stem 3s is the little plucky ARP sound. Okay, so that one is stem 3. We'll go back to our meshes. So here's our magazine. So now we know which stem it's reacting to, and we can choose whether we want it to translate, rotate, scale, any combination of the 3. For now, we just have it rotating on Z and translating on Z, so it jumps up in the air and it spins a little bit. Cool, and for now, let's turn these viewport tags back off, at least in game. Perfect. Okay, so with all these arrays, you have your index number, and they will all correlate to each other's properties. Where these audio stems, we have 0, 1, 2, and 3. In our reactive meshes and our lights, we always have our stem selection, so that would be 0, 1, 2, or 3. And again, you can add as many audio tracks as you would like and set the stem to match any of them, and it will react appropriately. Excuse me. Okay, so that is basic mesh reaction, and you can see for this scene, I do have 30 objects, and it's actually not that hard. This maybe took me 15 minutes to set up from scratch. So once you get the hang of it, it goes really fast, and the tagging system's a lifesaver because you never have to dig through these like, which mesh was which mesh. You just have this nice viewport tag, and you can jump right to it. So even if it does collide with stuff or might not be the cleanest, it's a lifesaver at the moment, and I'm sure you'll enjoy it too. Okay, for the audio reactive lights, they get a tag the same way the meshes do, but they will always be tied to the front of the light. So wherever the light is facing, that's what the tag is going to face, and will not update when using this tag camera like these mesh tags do. Oop. Okay, and with the lights, I have 7 added in this scene, pretty much just covering all these windows. Let me just hit simulate real fast. We'll jump outside, and as the sun goes down, we'll be able to see them react. Perfect. So they're all doing the same exact thing. They're all just kind of blending from a pastel green to purple, and they're all following that main melody. And the only options you really need to worry about is your contrast, which is how fast it's blending between these two colors based on loudness and softness, and the stem selection, which audio track it is reacting to, and of course the overall intensity. And just as with the static meshes, these lights will become movable as you add them to this array, so you do not have to worry about changing these. They will be set automatically once added to the index. Here we have our ultra dynamic sky and weather integration. We have our enable checkbox, which needs to be on for it to work. And the first drop down is our weather sounds. If you're using any storm or blizzard presets with the weather system, you can override their sound effects here. That way they don't clash so much with your audio that you're trying to use. So you can use this as you need. If this is not on, it will do the sounds based on whatever is the current weather preset. So it'll be no change from whatever you have set in UDW. We then have our start and end time and weather presets. This is the majority of what you'll probably be using. This lets us choose a custom preset for when the track starts. And I'm just using the default weather presets that came with it. You can always make your own. So there's a lot of options there. We have our transition length. We have a start and an end transition length, as well as a time of day. So when your track starts, if it's noon in the game, and you have this set to sunset, it's going to take 10 seconds for it to go from noon to sunset. And the same when the track is over, it'll take 10 seconds to go from sunset or 1800 to 1700. So you can also choose a song and weather preset. So in this current setup, when the track starts, we will get a thunderstorm over the course of 10 seconds. After the song is done, which is your audio track length, it will transition to the light rain. So I'm going to make this really short so we can see it in action. We'll leave these at 5 seconds and 5-second transition. And I'll make this extreme. We're going to go midnight, and then we're going to go noon. It's going to start with a thunderstorm. It's going to end with snow. So if we hit play, there we go. Got some lightning. Oh, and we're already back up. Here comes the snow. All right, so it is really that simple. You just have your 2 weather presets, how long they're going to transition, and your times of day at the start and the end. The custom lightning flash is a new feature I just added that will let you attach custom lightning bolts from the ultra dynamic weather system and tie them to a song stem. You have the stem you want them to react to. You have the threshold, so if a sound breaches the 0.3, it will trigger a lightning bolt. And after the lightning bolt is triggered, I currently have it on a 1-second delay. So after 1 second, it can then trigger again. So you can set this to be a wide gap if you want to just time it on the downbeats of a song, or you can make it low for a bunch of rapid lightning bolts if that's what you desire. You also have flash duration. So each time a bolt flashes, it will stay on screen between 1 and 3 seconds. Again, these can be changed as needed. So let's try this out really fast. We will make the song last a lot longer so we have some nighttime to work with. It's going to change fast. It's going to be a thunderstorm. Okay, so let's get our thunderstorm going. Let's turn on our custom lightning flash. And I'm going to make it trigger using the kick drum. Actually, you know what? I'm going to make it trigger using stem 3, which is, go down 3. That could be interesting. So let's try that. Could be a lot of bolts. The delay might be a little too much, but let's take it down to a 1/2 second, see what we get. And I still have my sequencer trigger on, don't I? Yes, I do. Let's turn that off, and now we can play. This is going nuts, but I'm getting no lightning. Let's lower my trigger threshold down to 0.1. Let's try this again. There we go. Now this house is getting lit up. Zeus is pissed. So the reason it is striking the house over and over is because I have a custom lightning target turned on. And if I turn on the visibility of the lightning target, you'll see there's this cube right here. This is the lightning target cube. So it spawns at 0, 0, 0. If I turn on the visibility, you can see it here. It's never going to render in game, but it will be an editor. And I just have the option to turn it off in editor. That way it's not in your way when you're working. Because you can make it wherever you want it to be. And that's where the lightning will strike. The spawn is set up in the clouds. So let me select it. Now you can see it right, that little yellow dot. So they recommend the lightning spawns at 70,000 on C. So that's what I have the default set to. And the target is at 111. I found when the target's at 000, the lightning is random. So 111 will actually follow the target, and that's why that is the default. If we turn off the custom lightning target and we simulate, we just get a normal lightning storm. Okay, the first thing we're going to go over is basic object reaction. So here I have a fresh scene, and the first thing I'm going to do, since this tutorial will also cover the ultra dynamic sky and weather integration, is I'm going to replace the light and cloud systems with the UDS system. Now this is not necessary for everybody. You can just use the regular audio reactive blueprint by itself and it'll work fine. But if you're using weather transitions and custom lightning strikes and stuff all timed with your audio, you're going to need to use the UDS. Now the UDS system includes the standard system, so you do not need both in your scene. So here we have our UDS, and the menu system over here is identical to this one because they're a parent-child blueprint. So this is the parent and UDS is the child. So first things first, we need to add our UDS into the scene. So let's grab our sky and our weather. Now since the weather defaults to rainy, let's go ahead and change the starting preset to partly cloudy. There we go. So this will pretty much match Unreal's default level, just a little nicer clouds. So object reaction. First thing we need to do is add something to react to. So let's add some audio. First thing I want to do is select my blueprint, and I want to lock a details panel to it. That way, as we go through and we're going through menus and adding things, you don't have to worry about expanding these every time you simulate to test, because it will collapse your rollouts. So first things first, let's go add some audio. We have under our audio dropdown, we have stems tracks. Let's add 4 elements to start with. We'll start with index 0. This will be stem or audio track 0. And I will add a drum track. This is a drum track. Let me just preview it really fast. Okay, cool. This will be perfect just to test out reaction times on objects. So let's start by creating the default cube. And go crazy and go sphere. And we'll go cube. Alright, so we have our cube. Now by default, all meshes that you drag into the scene are going to be static unless you have specified somewhere else for them to automatically be stationary or movable. But for this tutorial, most meshes that you run across are going to be set to static. Very few are going to be already set to movable, which is required for audio reactive to work correctly. But you do not need to set this manually. As you add your meshes to the reactive arrays, they will automatically update to movable. So let me demonstrate that real quick. Now that we have our drum stem in track 0, let's go to our reactive meshes rolled out. And we click plus, and let's add our cube. I can either see him here, or I can use my eyedrop tool and select him in viewport. Now if you watch the static here, as I click the cube, now it's movable. So again, any mesh you add is going to become movable. That way it works with all the dynamic scales and rotates, and however you have this thing react to music, it'll work correctly without throwing any kind of errors. You'll also notice I got a little tag on top. Now this is part of the asset tracking system. The tracking system will help you, especially as you expand these arrays and add many more objects. For instance, let's duplicate this guy 3 more times. Come on now. And let's add these 3 to the array as well. So let's unroll 1, 2, and 3. And I'll just use my eyedropper. Mesh 1, mesh 2, and mesh 3. And you'll see that all of the cubes have the default stem 0, which means they will react to our audio track 0. And let's give it a try. First, we need to uncheck this top box. This basically states that if it's selected, the audio track will not start when you play. It'll start when it's triggered in Sequencer. So make sure this is unchecked if you plan to just use Simulate. Cool, so we have our song, but we do not have any reaction yet. So let's go into our scale. Let's make box 0 scale on Z by a value of 3. Let's just see what that gives us. There we go. And then box 1. Let's make it scale on Y by a value of 3. And you see where this is going? Go to this guy and we'll set him to X, set him to 3. That should make these first 3 boxes react on the 3 different scale axes. There we go. Now let's make mesh 3 go a little nuts and do a little bit of everything. So we'll make him scale up on Z so he gets taller. We'll make it move, let's see which way, negative X. Let's do negative X. So we'll do X and set this to a negative value of maybe 150. And rotate on these 2 axes. We'll give this a value of 100. Let's see what happens. There we go. So that is basic mesh reaction. Each mesh will get its own tag. It'll be set to movable, and you have fine grain control over every axis. These values all work positive and negative. And just as an overall nuance, these values in the multipliers for all the scales, translates, and rotates, these are not like world units. These are not rotation degrees. This is basically 100 multiplied by the incoming audio. Now, the incoming audio is typically under a float value of 0.5. So this value might need to be higher to get a really extreme reaction. So yeah, just keep that in mind. This is not degrees, and these are not like world units. This is just a multiplier from the incoming audio. So it takes a little kind of testing to see what's going to work for each object, but I hope you have fun.